I'm going to help you set up your development environment, and to do that, we are going to use AlgoKit. So let's unpack what is AlgoKit. AlgoKit is your window into Web3. AlgoKit is a tool chain that allows you to bootstrap your development environment within VS Code. Plus, AlgoKit is a tool chain plus templates, and those templates are there to provide complete code samples for you so that you can quickly get started developing some novel projects. All there for you. Just select and go. We're going to go and do one here shortly. So AlgoKit is a tool chain plus templates plus your Web3 infrastructure. And that means that you have everything that you need in order to develop smart contracts on Algorand right there in your local development environment, including networks, a wallet, APIs, and a block explorer so that you can build and interact with your dApps as well. Networks pluralized. Why is that? Because AlgoKit allows you by default to install a local private network. And then it also allows you to connect to the testnet and to the mainnet so that you can deploy your application, test it locally, and then deploy it to testnet, get it all working there, and then finally to mainnet, all with one nice tool. So AlgoKit really is your window into Web3. Yeah, the last piece there is the beautiful block explorer that it has as well, so that you can see and interact with that. All right, so let's take a look at what the AlgoKit build process looks like. There are just 3 commands that you need to be familiar with. The first one being AlgoKit init, and what that does is it will ask you to select a template, then it will bootstrap your tool chain, and finally you will be able to modify and compile your source code. Once that's completed, you can issue the second command, AlgoKit localnet start. That is going to start up a local Algorand network on your local workstation. And from there, you can then use the third and final command, AlgoKit localnet explore, and that will pop up the Explorer, and we will be able to deploy that smart contract code and also interface with it and test it from a nice user interface. You'll have to first configure your dev wallet, and then you can deploy your smart contract, because of course you have to have a funded account from which to deploy your smart contract from. So we will see how to do that, and we will use the Beaker Studio in order to deploy and interface with that. So let's get to it. Here we go. What are the prerequisites? If you are Windows, you can use either Windows 11 or Windows 10 as long as you have Windows 10 build 19.0.41 or higher. The prerequisites for Windows specifically are going to be Docker, Python, and then WSL2, Git, and pipx. So those are the required ones. We highly recommend that you're using VS Code because we've got lots of great interfaces built in for AlgoKit using VS Code. On Mac OS, you can use it on the 3 most recent versions of Mac OS, so Big Sur, Monterey, and Ventura, and you can use it either on Apple Silicon or the Intel processors. No problem there. Prerequisites for installing AlgoKit on Mac OS are going to simply be Homebrew and Docker. And again, we will recommend that you use Visual Studio Code and any web browser except for Safari. Unfortunately, Safari does not like localhost, a little too strict on their security. So when we pop up the local Explorer, it doesn't work. Chrome's a good one, Firefox, doesn't matter. Edge, whatever, wherever you are, anything but Safari. All right, let's get through and begin taking a look at installing AlgoKit on your local machine. So first thing to note here is that in the top, I've got icons for the operating systems that you should pay attention to. So here, all of them, I'm recommending that you are installing VS Code because it's free, it's open source. You can get it at code.visualstudio.com, download it for your platform, and simply open up a terminal window, and we can do the rest of the commands there. All right, now if you are a Windows user, then you have to pay attention to this one. Linux and Mac, you can pause for just a moment here. WSL2 is going to be a requirement because Docker is going to require that. You can issue the command WSL -L-V to take a look to see if you have it installed already. In this example here, yes, it is installed and it is running. And importantly, I have something running in version 2. If you don't have it running, it's no problem. You can install it very easily by issuing the command down at the bottom, wsl-install, and it will go through and set up your environment for you. That's a Windows only thing. Flipping over to the Mac side, if you are a Mac, you can install Homebrew. You go to their website, brew.sh. They're down towards the bottom. There is the install script. So you just copy that and you paste that into a terminal window and you issue that and it will install Homebrew, and therefore you can install AlgoKit after a little bit later. So Homebrew is the Mac only thing. Git is required for all platforms. You can issue the command git-version to see if you have it installed. Any version is fine here. When you do that on Mac, it'll install the Xcode tools. On PC, it will have installed it as part of the WSL2 installation. So you'll have this here, but it is a requirement in all platforms. Docker is another important prerequisite here. If you are going to run a local network, this is what it is running inside of Docker containers. Make sure that you issue the command Docker version and then look importantly for the Docker server version. It should be 4.8 or higher. This one here shows that it's 4.15, so that one's good to go. All platforms need to have a version of Python that is version 3.10 or higher, so you can issue the command python -- version. Here you see 3.10.7. You can install it by following this link, going to python.org and installing the latest version there for you. Forgot to say on the previous one, it's docker.com and install the latest version there. All right, pipx is our final requirement. It is fairly easy to install. You can check if you have it by just issuing the command pipx -- version. Any version will be fine here. Scan the QR and learn how to install it there as well. All right, the installation process for installing AlgoKit is very simple. If you are on macOS, simply issue the command brew install Algorand Foundation /tap/AlgoKit, and it will download the latest version, and it uses the pipx installer built in there, and you will see the output down there at the bottom. AlgoKit was successfully installed. Easy peasy using Brew on macOS. If you are on any platform, you can use the command pipx install AlgoKit, and it will install it here locally just the same. And actually, that's what we are going to do now. We are going to build using AlgoKit. So let me start by bringing up my VS Code IDE here, make that maybe just a little bit bigger for you all. All right, very good. I'm going to issue the command pipx install AlgoKit. Here we go. All right, so it is going to go out and install the latest version, 1.0.1. using Python 3.10. All right, very good. So then the next thing that we want to do is recalling those commands, those 3 commands that we wanted to do. We are going to start with AlgoKit. AlgoKit init is our first one. And it is going to prompt us to select a project template. So here we have different templates here available. We're going to start today with the playground template. So I've used the arrow key to highlight playground. I'll hit enter. It's going to ask us what to name it. I'm going to name it playground. And here we go. Now it's going to ask me a series of questions. I'm just going to take the defaults for all of these. So it is going to bootstrap my environment and get us ready to go. And then you see that it automatically started up a new IDE, VS Code IDE for us here and brought us into that project template straight away. So we've got the README file that is opened here for us, and it explains how we can use this. What we're going to do is to pop into the playground folder, and we are going to take a look at the hello world.py file. So this is a very basic smart contract that is going to say hello back to us when we supply a string to it. All right, so I want to build the code. Okay, so what I need to do is right click on the build.py file here and run this in the terminal. What this does is simply say, hey, I want to build this Hello World application and I want to stick the output into the artifacts folder. So let's take a look at what it has actually sent out for us in this artifacts folder here. We have that approval teal file, so Joe showed you a little bit of teal, and then we also have an application specification file here, so application.json. It tells us that we have made this new application here. We have the source code for it here. We have the schema for it here, and we have named the contract Hello World app, and we have all of the methods that it includes here, which is just this one called hello, and it is expecting that we will send a string to it, and it is going to then return us a string. So let's actually now go and deploy this smart contract. But before we deploy it, we're going to have to make sure that we have a network running. So we're going to run our second command, AlgoKit localnet start. This is going to pull down a Docker container and start up our local network. And what we can do then is issue our third command, which is AlgoKit localnet explore. All right, here we go. We are opening up the Explorer. I'm going to make this a little bit bigger here so that we can, maybe I can't make it bigger yet. I got to do this. Okay, so here's our Explorer. So we are now connected to our local network running on our machine. We have a series of accounts that are already there and funded, but we don't have any transactions yet on this, no applications or anything. All right, of course not. It's a brand new network. So let's start by clicking on the dev wallets on the left-hand side here, and we are going to create a wallet. Typically that is not there, but we are going to create a wallet, and when we do, it generates a brand new address. It funds it with 100 test algo into that account. If we wanted to, we could dispense it again, and now we would see that we get 100 more algos. There we now want to connect our wallet here, because in Web3, when we're using a web UI, we need to have a wallet which holds the private keys so that we can actually sign transactions. So we are going to connect this wallet, and we are going to select the dev wallet here. Now notice we now have this account that starts to Victor Hotel is now connected here. So we have that linked. Now we are going to head over. Oh, actually, let me just show you that those transactions now have showed up, right? So we see that we have a payment transaction here that went through. Of course, that was us funding that account. So let's now head over to our Beaker Studio, because the application that we created was actually created with Beaker, and we are going to import this application using an app spec file. So what we are going to do is head over to Algorand, Playground, Hello World, dig for it now, artifacts, and we are going to find that application.json file here. And when we import that, it has all of the information that we provided in our playground.py file. So we have the Hello World app is its name, talks about our local and global state. We don't have any of those defined for this very simple application, but we can see the approval program that we have here. We can see that method's signature here. So a name of our method is hello, it's expecting a string, and it will return a string as well. A clear program is there, and then if we scroll down to the bottom, we can see then the application binary interface, the ABI for this one that we have here is just a single method called hello. And as we can see here, it'll take a string and expect a string, and we can execute that here once we actually get it deployed. So let's scroll back up to the top here, and we can create an application. All right, so let's create this app. It's going to use our spec file that we have provided, so we can simply just hit create. When we do this, it's going to use our dev wallet in order to sign this transaction. That goes very quickly because in dev mode here, each time that we send a transaction, it gets approved automatically. So there we have our application deployed. We can tell it's deployed because up here in the upper, we see that the app ID is now 3. Prior, that was blank. So we can now scroll back down here to the bottom and we can take a look at that method, and we can then hit the execute button. Now, this, it says hello. It prompts us for the arguments here. It wants a string. So if we say hello, algorithms, we can then execute this and we will see the response. So it returned us a string, and the string that it returned is hello, comma, algodevs. So hello, algodevs, you have successfully deployed and then executed your first smart contract and transaction on Algorand Network. Congratulations, you have progressed down that continuum towards becoming an algodev. Let's take a look a little bit at some of the code that is in there. So if I come back here, what we executed was this. And if we take a look at this, we'll see that at the beginning, we simply imported Beaker and PyTeal. We then use the application class to define a new application called Hello World App, and we assign that to our app. And then we could define a new method called hello, and we have the name being defined as a PyTeal ABI string. And then we have output defined as a PyTeal ABI string as well. All right, so we have this interesting little star separator in here. So Python expects arguments that are going to be passed in are going to be to the left of the star, and values that are going to be returned to the right of that star. And then this is going to be a PyTeal expression. Everything that we do here within the Beaker framework is going to be a PyTeal expression. So we are going to return the expression, and this expression is going to set the value for output to the concatenation of some bytes, hello, comma, space, along with the name that we pass in. We're going to get that, and we are going to concatenate those together. We are going to stuff them into the value of output, and that's what we saw returned to us. The last piece that we will do is then decorate this method with the app.external decorator, which will then put it inside of our contract specification file so that we have it as an external method. So we see then our method here, hello, having the string type as the argument, and then also the return type here.